You've probably heard the argument that AI is just a really, really good parrot, right? That it's just mindlessly repeating patterns it saw in its training data. But if that's all it is, how in the world can it solve problems it's never seen before? Well, today we're going to crack open that idea and go way beyond the parrot to understand how a digital mind is actually built to really think about it. We're asking these things to write code, help with new scientific discoveries, all sorts of complex stuff. So what's actually going on under the hood? When we ask it to do more than just spit back a fact, what does it even mean for an AI to think its way to a solution? The difference here is just massive. A parrot, it just mimics. It repeats what it's heard. But a real problem solver, that's a whole different beast. It can take a challenge it's never encountered, break it down into smaller, logical pieces, explore a bunch of different paths, and then actually build a new answer. So let's look at how engineers are pulling this off. Right, and let's be super clear about this from the get-go. This isn't magic, not even close. It's actually a series of incredibly clever engineering steps, all designed to give a large language model the power to reason. Let's see how they build this thing from the ground up. The best way to think about it is like this. You can't build a house with just a hammer, right? You need a whole toolbox. Well, building an AI that can truly reason is the same thing. It requires a specific set of tools, and each one has a very particular job. So we're going to open up that toolbox and look at these tools one by one. Okay, first things first. Every system that thinks needs a foundation, a basic structure to even get started. For an AI, we call this its core architecture. This is the blueprint. Before an AI learns a single thing, it has this fundamental structure. You can almost think of it like the basic neural wiring in a newborn's brain. Now, this blueprint doesn't have any knowledge in it, not yet. But what it does is create the potential for knowledge. It sets up the pathways for how information can flow and connect, which is the absolute foundation for reasoning. So we have our basic brain structure. That's great. But how do you teach it brand new, super specialized skills without having to spend, years and millions of dollars retraining the entire thing from scratch? Well, the answer is this really cool technique called parameter efficient fine-tuning, or PEFT for short. So an AI's parameters, you can think of them as billions of tiny little knobs and dials that control everything it knows and can do. Instead of retuning all of those billions of dials, PEFT is like sending the AI to a specialist school. You don't have to reteach it everything it already knows. You just efficiently insert these small, highly focused modules that teach it a very specific new skill, like advanced math or logical deduction. And there are a couple of really popular ways to do this. One is called adapter tuning. This is kind of like surgically implanting tiny new mini brains right into the AI's existing structure, each one a specialist for a new task. Another method, LoRA, does something different. It basically freezes the original brain, all its general knowledge, and then adds a couple of small, trainable layers that act as a guide, steering all that existing knowledge towards mastering a new skill. And get this is what's so brilliant. It's incredibly efficient. For example, one of these adapter methods added just 1.2 million new parameters to a model that already had 7 billion. That is a tiny, tiny fraction of the original, and yet that small addition was enough to teach the model a major new reasoning skill in less than an hour. This is a total game changer. It means we can create whole armies of specialized AIs, not just a few giant general-purpose ones. Okay, so our AI has a brain, and now it has some specialized skills. But how do we make sure it uses all that intelligence in a way that's actually helpful and, safe? We've got to give it some rules to live by. This whole process is called alignment. Now, the old way, RLHF, was pretty complicated. It was almost like hiring a second AI whose only job was to grade the first one's homework, and that could get messy and unstable. The newer method, direct preference optimization, or DPO, is just smarter. Instead of needing a separate grader, it builds our preferences, what we think is helpful and safe, directly into the AI's learning process from the start. It gives it a much more reliable internal compass. And here's why that matters so much. DPO makes this whole alignment process way simpler and more stable. And what that means for you and me is that the AI is much more likely to follow a line of reasoning that isn't just logically correct, but is also safe and actually aligned with what we want it to do, without going off the rails. All right, so now we have an AI that's built, it's trained with special skills, and it's aligned with our values. So how does it actually go about tackling a really hard problem? Well, it uses specific strategies, ways of thinking. So the most basic method is called chain of thought, and it's pretty much exactly what it sounds like. The AI thinks through a problem one step at a time, in a perfectly straight line. A leads to B, which leads to C, and so on. And this works great for a lot of things, but it has a big weakness. If it makes just one mistake early in the chain, the whole thing can fall apart. So, to get around that, engineers came up with something much more advanced: tree of thought. Now, instead of just one single path, the AI explores multiple lines of reasoning all at the same time, like the branches of a tree. It can weigh different possibilities, and if one path hits a dead end, no big deal. It just backtracks and tries a more promising branch. Honestly, it's the difference between making a simple to-do list versus running a full-on brainstorming session. So after exploring all those different branches, how does it pick the single best answer? It uses this neat trick called self-consistency. Basically, it solves the same problem over and over again, using different logical paths each time. And then it just picks the answer that shows up the most often. It's like reasoning by majority vote, which makes the final conclusion way more robust. So, there you have it, the AI reasoning toolbox, all laid out. You start with a basic blueprint. Then you give it fast-tracked specialist training. You install a moral compass to keep it on the straight and narrow. And finally, you give it these advanced thinking methods to really tackle complex problems. And that is how you go from being a simple parrot to a genuine problem solver. See, we've gone way beyond just building something that can repeat what it's been told. We've actually engineered a process for reasoning. So the real question for us now isn't just how it thinks. It's what are the big, challenging, important problems we should be asking it to think about next.